Okay, this is a video on solving simultaneous equations using the elimination method. Last lesson we looked at using the guess and check method, where you're guessing values of x and y that would satisfy both equations. Now obviously that could take a very long time, sometimes successful, sometimes not successful. Another method we looked at last lesson was to graph both these straight lines. These are equations of straight lines, and to read off the point of intersection. That is another way of solving those simultaneous equations. Now, when you're asked to solve a pair of simultaneous equations, you will have two pronumerals or two variables, being x and y, or it could be something else. And when you've got two variables like x and y, you actually need two equations. So here I've got my first equation with x and y, and there's my second equation with x and y. So if you've got two unknowns like x and y, or two variables, you need two equations to solve for x and y, and both those equations would need to have x and y in them. So that is what simultaneous equations are, is when you're solving them simultaneously or together. Also, last lesson we looked at the substitution method, where we made y the subject of the formula. Wait, I think there's a little mistake here. We just get rid of that there. So lesson we looked at making y the subject here, and then substituting it into the second equation. Now that was last lesson's video. This lesson we're looking at solving. So this is another algebraic method that we're looking at, and it's solving simultaneous equations using the elimination method. Now, when you think of the word elimination, it means to get rid of something. So when we use this method, we will end up eliminating one of the pronumerals, in one of the earlier steps of our process. So here are our two equations. Okay, so we have to solve these pairs of simultaneous equations using the elimination method. And the equations are 2x minus y equals 5, and I call that equation 1. So when you call it equation 1, I like to put it in a circle. And I've got 2x minus 7y equals 59. That's equation 2. Now, we want to eliminate either one of the pronumerals, either x's or the y's. Now, what we look for is if the coefficient, now we can see the x's here, and they're both 2x. Okay, so the coefficients of both of the x's in equations 1 and 2 are the same. So, and they're the same number, and they're also the same size. So, just thinking over here, what I need to do, so whenever you're solving simultaneous equations, first we need coefficients of either the x's or the y's to be the same, and if they are, we either subtract the two equations, so we might do equation 1 minus 2 or equation 2 minus 1, or we will add the two equations. So what we've got to do, we look at the two x's and we say, well, if I've got 2x and go minus 2x, then I will get 0. So when the coefficients of the x's or the y's are the same sign and the same size, so same in number, same in sign, if I do 2x minus 2x, then I'll eliminate my x's completely. But if I did, so that means I should subtract the equations. But if I decided to add the two equations, and I do 2x plus 2x, for example, I will get 4x. So doing that does not eliminate the x's. So the decision here will be that I'm going to do equation 1 or equation 2 minus equation 1. It does not matter which way you do it. So I'm going to do equation 1 minus equation 2. Now we always write our instructions for what we're doing. So we label our two equations, equation 1 and 2. We look for any pronumerals, coefficients of pronumerals that are the same. And if they're also the same sign, then we subtract, because 2x minus, so I'm subtracting, 2x minus 2x is 0. Then I've got negative y minus negative 7y. So I write negative y minus, so I'm doing whatever the y value here is, minus, and that's my minus, and then the y value here, minus 7y. That is equal to 5 minus 59. So remembering, I've decided to do equation 1 minus equation 2. So going through that again, 2x, just do this in orange, 2x minus 2x is 0, so I don't need to write that. Negative y minus negative 7y is negative y minus negative 7y. Then I've got 5 minus 59. So just on the next row, just simplifying that, I've really got negative y minus negative 7y is plus 7y equals 5 minus 59. Well, that would be negative 54. Now, negative y plus 7y is 6y is negative 54. And solving this for y, I get that y is negative 54 over 6, which is negative 9. So I've worked out what y is. Now, you don't stop there. These are simultaneous equations where I'm trying to work out the value of x and y that satisfies both equations. So I'm halfway there. I've got that, that y equals negative 9, so I need to substitute that into equations 1 and 2, or 2. And you choose the equation that is easier to substitute into. So I'm going to substitute into equation 1. The reason is equation 1 has the smaller numbers, and so the substitution will be easy. So I'm subbing y equals negative 9 into equation 1. So I start writing out equation 1 again, 2x minus, and instead of writing y, I write down what my y is, which is negative 9, is equal to 5. This means that 2x plus 9 is 5. So 2x is 5 minus 9, which is negative 4. Therefore, x is, now that will be negative 4 over 2, which is negative 2. And so therefore my solution is that x is negative 2 and y is negative 9. So if I now substitute, now I don't need to substitute, but if I did, if I substituted x is negative 2, y is negative 9 into the first equation, I would get 2 times negative 2 is negative 4 minus negative 9, so that's negative 4 plus 9 is 5. That works. If I substituted these into the second equation, and I'll just do that one down here, 2 times negative 2 minus 7 times negative 9, and let's see what that is. 2 times negative 2 is negative 4, minus 7 times negative 9 is plus 63, and the answer I get is 59, which is what is there. So, with simultaneous equations, if you've got a bit of time up your sleeve, you can check that your answers work in both equations. Now, I don't really need to check it in one because I just did substitute into one here and got that answer. So the idea would be to substitute this into equation 2 and just make sure that you get the right answer. So you can always tell if your answers are correct with simultaneous equations. Okay, I'm going to look at another example now. Example 2. Now, here is my second example, and it is the following. I've got 3x minus y equals 20, so I want to solve these two equations simultaneously. So here's my first one. 3x minus y is 20, that's equation 1. And x minus y equals 8, that's equation 2. Now I can clearly see that my y values have the same coefficient, and the coefficient of the y's are negative 1. Because when you just see y, it means 1y. So I've got minus 1y and minus 1y. Now I've got to decide, do I add these two equations or subtract them? Look, when they are identical in all ways, so if you do something take away itself, you always end up with 0. So we would need to subtract these equations. Now I'm going to show that to you over here, because a lot of people will get confused when they're both negative here. A lot of people will try to add them. But what I'm going to do, let's subtract. So if I was doing equation 1 minus 2, let me just look at what would happen with the y's. I've got negative y, and then I'm doing minus. So whatever I've got there, minus whatever I've got there, which is negative y. So negative y minus negative y is negative y plus y, which happens to be 0. So if I subtract these two equations, if I do negative y minus negative y, I end up with 0, which means I've eliminated the y. This is the elimination method where I'm trying to either get rid of the y's or the x's. That way I can work out, so if I get rid of the y's, I can work out the x first. And once I've worked out the x, I can substitute it back into one of these equations and work out the y. So the very first step, you need to eliminate either x or y. Obviously, it's easier to eliminate y's here. Now, let's say you weren't sure about this and you decided to add the two equations together. So you've got negative y and you're deciding to go plus negative y. Now, that's just really negative y minus y. Now, these are like terms. That's negative 1y minus 1y is negative 2y. So be very careful. If you were to add equations 1 and 2, the y's would end up as minus 2y or negative 2y, which has not eliminated the y's at all. So we are going to subtract the equations. So let's go. We've got 3x minus x is 2x. Negative y minus negative y is negative y plus y, and a negative and a positive cancel, so you get 0. And 20 take away 8 is 12. So I've got 2x equals 12. Notice I've written my instruction here, what I'm doing. So therefore we can see that x is 12 divided by 2, which is 6. Now we can substitute x is 6 into, I think I'm going to put it into equation 2 because it looks easier. So substitute x equals 6 into equation 2, and I get 6 take away y is 8. So let's take this minus y to the other side, and I'll get plus y. Keep this 6 here and bring the 8 over, and I get 6 minus 8. So I'll take this minus y over there to make it positive, bring this 8 over here. 6 minus 8 is negative 2. In other words, y is negative 2. Now, if you just see 6 minus negative 2 means 6 plus 2 is 8, so that works. So therefore, our solution to this simultaneous equation is x is 6, y is negative 2. Now, of course, you can check that in equation 1. We've just substituted into equation 2, so we're pretty sure it's right there. So let's just check it. So in equation 1, 3 times 6, so 3 times whatever x is, which is 6, minus whatever y is, which is negative 2. Let's see what that is. We get 18 for the 3 times 6, minus negative 2 means plus 2, and we get 20, and that is what we've got here on the right-hand side. Therefore, it is, our solution is correct. So in these first two examples, we have had two pronumerals. We have had like pronumerals with the same, that were identical. They had the same coefficient and the same number in front of them and the same sign as well. Now, if you've got two things that are identical, the way to eliminate them is to do one number or one of those things minus the other. So therefore, the rule is if two pronumerals have coefficients which are identical, equal in number and sign, then you will subtract the corresponding terms. What I mean by that is you subtract the x's, you subtract the y's, and you subtract the numbers, okay? All right, we're going to look at a few more examples now. Okay, example 3. And in this example, you're asked to solve the following pairs of simultaneous equations, again using the elimination method. So let's look at this first question. We've got negative 5x plus y equals 3, call that equation 1. And equation 2 is 5x plus 3y is 29, we'll call that equation 2. Now, we can see that the x's have the same number in front of them, but the sign of the, we've got negative 5 here, and we've got positive 5 there. So we are either going to add these two together or subtract them. So let's try adding first. So if you do negative 5x plus 5x, that's like doing negative 5 plus 5, for example. Your answer will be 0. If you've got two opposites, and that's what we've got there, two exact opposites, and you add them together, you'll get 0. You might be confused again and think, well, I think I need to subtract. So let's see. So if we added, we can see that we get 0 if we add the two equations. So if we do equation 1 plus equation 2, we can see that we will eliminate the x's, okay? But let's say you try to do equation 1 minus equation 2. So we go negative 5x, then we go minus whatever this one is, 5x. Well, if I do negative 5x minus 5x, I get negative 10x. Now that is not eliminating the x's. So I've just doubled the value of the first one, really. So this, if we subtract the equations, I will not eliminate the x's. So obviously subtracting is not the way to go. So we've decided we're going to add these two equations together. So I've got equation 1 plus 2. So negative 5x plus 5x is 0. Then I've got y plus 3y is 4y. And 3 plus 29 is 32. So therefore y is 32 divided by 4, which is 8. Okay, so now that we've worked out y, we're going to substitute it into either equation 1 or 2. I'm going to substitute it into equation 1. So substitute y equals 8 into equation 1. And the reason is I've just got a normal y there and I've got a 3y here, so it seems to be a bit easier. So I get negative 5x plus whatever y is, which is 8, equals 3. Now let's put these numbers here together. So I've got negative 5x is 3 minus 8, bringing that over. So negative 5x is negative 5. Now be very careful here. Okay, to get the x on its own, I need to divide by negative 5. It's this negative 5 I need to move away. So therefore, x is negative 5 divided by negative 5 is 1. Now, if you have a look here, negative 5 times 1 is negative 5 because a negative times a positive is a negative. Please don't put that the answer here is negative 1 because negative 5 times negative 1 would be positive 5, which would not be correct. So therefore, we get that x is 1. Now that we know what x is, we're going to substitute x is 1 into either of these equations. I'm going to go into equation, it doesn't matter which one, I'll actually go into equation 1 again. So substitute x is 1 into equation 1, so I get negative 5 times 1 plus y equals 3. Now that's negative 5 plus y is 3. Taking this minus 5 over to the other side, I get the 3 plus 5, and so I get that y is 8. And therefore my solution to this simultaneous equation is x equals 1, y equals 8. Now we've just substituted into equation 1, so we know that's correct for that. Let's have a quick look if we put x is 1, y is 8 into equation 2. 5 times 1 is 5. 3 times 8 is 24. 5 plus 24 is 29. So that solution is correct. Okay. Now for another example. Okay, example 4 is to solve these two simultaneous equations using the elimination method. So we've got 7x minus 2y equals 37. I'll call that equation 1. And I've got 3x plus 2y equals 13. I'll call that equation 2. Now if we look at these two equations, the x's, the coefficient of the x's aren't anywhere near the same. But the coefficient of the y's are almost, well, they are the same, but they're different signs. So you've got to decide, do I add them together or do I subtract them? Well, let's try over here. So if I go minus 2y plus 2y, it becomes minus 2y plus 2y, which is 0. So therefore, if I add, remember, if you add direct opposites together, you will get 0 and eliminate them. So what we're going to do here is equation 1 plus equation 2. Because if we did equation 1 minus equation 2, we would get negative 2y minus plus 2y, or just minus 2y, and we'd get negative 4. And therefore we have not eliminated the y's, so that's no good. So we're going to do equation 1 plus equation 2. Now don't forget to write your instructions here on the side. So let's do that. 7x plus 3x is 10x. Minus 2y plus 2y is 0. 37 plus 13 is 50. We can clearly see here that x is 50 divided by 10, which is 5. Now we can substitute x equals 5 into either equation. I think I'm going to put it into equation 2. So we get 3 times 5, which is 3x, plus 2y is 13. Now 3 times 5 is 15, plus 2y is 13. Taking this 15 over to the other side, I get 13 minus 15, and so 2y is negative 2. So here I need to move this 2 away from the y, and this is 2 times y, so the opposite of times is divide, so I get negative 2 divided by 2, which is negative 1. Notice a positive has to be multiplied by a negative to give you the negative there. So our solution here is x equals 5, y equals negative 1. Now I've just substituted into equation 2, so let's just check our answer with equation 1. I'll do that down here. 7 times x, which is 7 times 5, minus 2 times negative 1. Let's see what we get. 7 times 5 is 35, minus 2 times negative 1 is plus 2, and the answer we get is 37, which is correct. And so therefore, the solution to our equation is x equals 5, y equals negative 1. Now in examples 3 and 4, the numbers in front of the one of the pronumerals was the same but opposite in sign. So if two pronumerals have coefficients which are numerically the same but opposite in sign, what we do is we add. So we add the corresponding terms. In other words, we will add the x's, we will add the y terms together, and we will add the numbers together. Okay?